All right, we're gonna take a look at the first part of real numbers. So we're gonna get ourselves familiar with the set of numbers. The natural number starts from 1 all the way to infinity. The whole number would be the like natural numbers, except we include 0 in there. Integers would be all the number from negative infinity to positive infinity. You notice that the number in between are not included in any of these sets. So 1.2 is not part of the natural number. It has to be a whole number. Rational numbers would be like P over Q. Irrational numbers and rational numbers, and everything would be under the real numbers. Can somebody tell me the example of irrational number? Irrational number. Can somebody give me example of irrational number?
Irrational or rational?
Irrational.
It's not a number.
Okay. What's the difference between rational number and irrational number? Let's put it that way.
0.
When the number after the decimal points terminates to 0 or repeat itself, then those numbers considered to be a rational number. A rational number would be like 4 over 2, which is 2, right? The remainder would be 0. If the remainder is 0, or if the remainder repeats itself, okay, like 1/3. What do you get when you get 1/3? You get 0.333333, right? So if the remainder repeats itself, or the remainder turns out to be equal to 0, then those numbers considered to be a rational number. When the digit after the decimal points keep going up or down irrationally, like put pi in your calculator. Okay, when you put pi in your calculator, what numbers do you get? Okay, pi, yeah, would be 3.14, right? After this digit, the number goes up or down irrationally. 15, 92, 654, and I'm going to put 3 dots here that this goes forever. So if the digit keep going up or down irrationally, those considered to be irrational number. Another example would be like square root of 2. Square root of prime numbers are irrational also. So if you put square root of 2 in your calculator, what do you get? You get 1.4142135562. Again, this number goes forever. Keep going up or down forever. So however, if you have a numbers like 4 over 2 or 1/2 becomes 0.5, stops right there. Or 1/3. 1/3 would be 0.333333. If the digit repeats itself, is rational. If the remainder goes to 0, is rational. The only time is irrational would be the example like pi, square root of 2. Those are the considered to be irrational numbers. So these are the set of numbers you need to get yourself familiar with. Now, the set of real numbers on the number line, if you look at it, that's considered to be everything, all the way from negative infinity and goes all the way to the positive infinity. So the rectangular coordinate system is something that we're going to use for graphing, and this is created by René Descartes and in that year. So we're still going to use this for x-axis and y-axis. So the vertical line corresponds to the y-axis, and the horizontal line, which is perpendicular to that, is correspond to x-axis. And this is what we're going to use for graphing linear equations. And you all probably seen this before. As you can see, these can be divided into different sections. So these are all divided into one unit in this case. And the first one corresponds to the first quadrant, and then so on the second, third, and fourth. So if you have a number right in the 0, 0, that's considered to be the origin. that would be origin 0, 0. So if you have a number in the second quadrant, like A and B, as you can see, the x-axis corresponds to the negative number, and the y-axis corresponds to the positive number in this case. There are some viewing window that you want to get yourself familiar with your graphing calculator that allow you to see the whole graph on that viewing window. Since we all are using different graphing calculator, perhaps I would suggest that see me perhaps before the class or after the class and show me your calculator if you have a problem with any part of your calculator. YouTube would be a good place to also search for any instructions you need for your graphing calculator. So we also need to get yourself familiar with approximate the number. So if you have a number like 1.3782, these are totally should be reviewed for all of you. You should be able to round out to the nearest tenth, hundredths, thousands, and so on. So if you round the number to the nearest tenth, so you look at the hundredth digit, if it's 5 or more, you would add 1 to this digit, like this becomes 1.4. If you are rounding this to the nearest hundredth, you look at the thousandth digit. Again, if it's 5 or more, you add 1 to this digit, so this one becomes 1.38. And for thousandth digit, this is 10th, 100, thousandths, you look at the 10,000 digits. If it's less than 5, you don't add anything, so this stays 8. And these would be some examples you can explore. I should know all that already. Finding a root on calculator. So you would, again, you have a different calculator. If you have a problem with any of those, let me know. Square root of 23. So if you enter that in your calculator, you can write it as 23 to the power of 1/2. If you recall, if I have nth root of x to the power of m, I should be able to write that as exponent. So I would write that x to the power of m over n. Okay, so if I'm writing the square root of 23, the root here, there's no number here, it means it's 2. And the exponents here, when there's no number, is 1. So this is really is 23 to the power of 1/2. 1/2. So if it was cubed, like in this case here, if I have cube root of 87, that's the same as 87 to the power of 1/3, and so on. So a lot of calculators, they have cubed, and all calculators should have a square root. But if you don't have like the 4th root or 5th root, then you're going to raise it to the power of 1/5 or 1/6. So in that case, if you put 80, if you want to calculate a cube root of 87, if your calculator doesn't have that function, you can raise 87 to the power of 1/3, and that should give you the answer. And so as the next one, if I want to calculate the 4th root of 12, that's the same as 12 to the power of 1/4. So if I raise that to the power of 1/4, that gives me the answer. So these are some examples here. We want to follow the order of operation for these. Again, these are totally should be review for all of you. So you, at the top of the fraction here, if you subtract 1.4 from 3.8 and then divide the sum of 3.5 to 5.4 and divide that, you would get 0.27. So for those of you reviewing these video clips, it's a good idea to pause the session and grab your calculator if you don't have it right now, and then see if you can get these results. So for this one, if you raise pi to the power of 4 multiplied by 3 and subtract 9 squared from that, you should get 211.23. And for the next one, you should get 5.83. So this is how you can test to see if you know how to do the simple calculation with your calculators, where you need to enter the numbers in there. The next thing is the Pythagorean theorem. So everybody should know that one, which the hypotenuse c squared is equal to the sum of square of the other side. So c squared, which is the hypotenuse, is equal to a squared plus b squared. And you probably recall that If any of the side is missing, we tried, we did that before. So we look at 13 squared, which is a hypotenuse, is equal to 12 squared plus b squared. So in this case, we plug the number and you solve for b. You would isolate the b, and of course you can use a calculator. B squared we call 25. So b would be square root of that, which is 5. So if you have something square, if I have x squared is equal to a number, x would be equal to plus and minus the square root of that number. Plus and minus because we have two. This is a second order equation. We should get two solutions. So in this case, you have b squared is equal to 25. Then b must be equal to square root of 25 or 5. We don't care about the negative of that because the length cannot be negative. Okay, distance formula is something that you probably seen in the past. You should have, and make sure you remember it. If you have a distance between 2 points, we're going to use this formula here: x2 minus x1 squared plus y2 minus y1 squared, and we take a square root of that, and that's what you use for finding the distance. So this would be example. If I have 2 points, you label them point 1 and point 2. You call them x1, x2, y2, y1, and you would simply plug it into that formula. So in this case, you can call the first one point 1. So that would be x1, y1. You're going to call this point 2. That would be x2, y2. And you just simply substitute that into this formula. And you can use your calculator. You get square root of 157. Midpoint is another one formula that you should remember. Midpoint between 2 points, would you just add up the x1 and x2 divided by 2, and y2 plus y1 divided by 2. That would be the second part. So here we have to use the midpoint using this example. If I have these 2 points, we can label them like we did with the other one. We can call this x1, y1, x2, y2. You add the x's divided by 2 and add the y's, and that would be the midpoint there. Okay, so here we have two example here where it says apply the midpoint formula. So this would be like a word problem here for quarters after launch the iPad, about 19.5 million were sold. After 10 quarters, about 99 million iPads were sold. Use the midpoint formula to estimate how many iPads were sold 7 quarters after this launch. So what we need to do here in this example is to consider that the quarter 7 lies between the quarter 4 and 10. Okay, that would be like a midpoint. So basically it's a midpoint problem. So if you take a look at those 2 points as 2 given points, right in the middle of those would be how many iPads sold in quarter 7. So that would be our estimate would be 59.25 million goods sold. So that would be one example of using the midpoint for this word problem. Okay, here we're gonna move on to linear functions, equation, and inequality. So introduction to relation and functions. We need to get ourselves familiar with set builder notation and interval notation. Make sure you know how to write from one to another. And we're going to look at some examples here. I'm going to let you read through this page. You can pause the session at this point and read through that. But let's take a look at some examples. The first one here that we have here says x greater than -2. This is a set builder notation. X is greater than -2. If you want to write it as an interval notation, you will write it as open parentheses -2, comma, infinity. Let's see how that works. if I go ahead and graph this line, if I draw the line here and locate -2, this is -1, this is -2, x is greater than -2. Would the solution would be to the right of -2 or left of -2? To the right, okay. X is greater than -2 would be all the numbers to the right. So it would be a good idea to graph this sometimes. So the set builder notation would be x greater than -2, like that. And you notice that I'm not including this endpoints, so I'm going to show this as a little circle, not filled, or sometimes they show that with a parentheses. Parentheses means that endpoint is not included. A lot of time you see it like a parentheses. Okay, so if I want to write this as an interval notation, the interval notation would be very much like the graph. So you use a parentheses, look, parentheses, from -2, then you put comma, go all the way to what? Plus infinity. So you put plus infinity. And when you go to plus or minus infinity, you always use parentheses because the endpoints is not defined. So therefore, you can see the interval notation is from -2 to the infinity. Now, if I were going to include the endpoints, then I have to use the brackets instead of the parentheses. So we're going to take a look at more examples here. So this pretty much sum all the lot of different possibilities you could see. So if I have x is greater than a, means all the number to the right of a, right? And if I want to write the interval notation, I put parentheses, a, comma, plus infinity, like I showed you. So, however, if I have x is greater or equal to a, means all the numbers that are larger than a, but including the a. So instead of parentheses, I'm going to using brackets. Therefore, the interval notation would be very much like the graph, would be brackets, a, comma, infinity. Okay, let's take a look at another one. All the number between a and b, including a and b. So it would be all the number between a and b. I'm going to use the brackets to show the endpoints are included. And as you can see, the interval notation kind of looks like a graph. Brackets a, comma, b means all the number from a to b. Okay, let me go ahead and look at the next one. So the question here is, when we use the parentheses or brackets again, if the endpoints is not included, like in this case, doesn't say equal to, so you're going to use parentheses like that. Okay, and the interval notation also would be parentheses a, comma, b. But for infinity, you always use parentheses because the endpoint is not defined. Right. Since you're away from my microphone, I'm going to repeat that. Basically, your graph and your interval notation would be very similar. If you look at the graph, you can kind of figure out how the interval notation should look like exactly. But set builder notation is what we used to use, and that's how we use that one. Very good. Okay, so let's move on to the next one. So the writing interval notation for these ones. So these are like examples we can look at. How would I write all the numbers between -3 and 5, including 5, not including -3? So I need to use a parentheses for the -3, because I'm not going to include -3, comma, 5, and then I'm going to use brackets. Okay, so that's how you write the interval notation. Let's take a look at the next one. X is less than or equal to 3. If you graph some of these, would be probably a little bit more clear. Let me graph this one for you. This would be 0, this would be 1, 2, 3, this is 3 right here. All the number greater than 3 would be to the right of 3, including that. So I'm going to put the brackets here. So that's how you use the, this would be less than, so that would be to the other side. This would be x is greater or equal to 3. So less than or equal to 3 would be, if this is 3 here, less than, that would be to the left of that. That would be less than. I'm going to use a bracket. So that would be all the number that are less than or equal to 3. So if I want to write this interval notation, would be all the number from -infinity, like here, and all the way to 3. Brackets means the endpoint is included. If I were going to write x is greater or equal to 3 as the interval notation, I would use brackets, 3, comma, plus infinity, parentheses. This is how you would write x is greater than 3 in interval notation. That would be less than 3 in interval notation. And the next one, x is greater than 3. Okay, so we did that already here. The only thing is you use a parentheses here because the endpoint is not included. If you don't want to include the endpoint, you put parentheses 3, comma, infinity, and that's how you show that. So you should be able to write the interval notation and set builder notation in any graph. A relation is a set of order pairs. So in this case, if I look at x and y, x here correspond to the domain, and y here correspond to the range. So if you remember that, x correspond to the domain, y correspond to the range. That's the first thing you want to remember. So in this example here, if I have a bunch of order pairs that correspond to maybe a graph of something, so in this case, the domain would be 1, -2, and 3, and your range would be 2, 5, -1. And if you were going to graph this, we can locate these numbers. 1, 2, you go on the x-axis, you go 1, on the y-axis, you go to 2. So this would be the point 1 and 2, and this one would be 3 and -1, 3 and -1, and so on. This would be -2 and 5. Graph of relation, the graph of a line or curve in the xy plane correspond to the relation. So graph of straight line would be a relation. Later we're going to look at the different conics, parabola, hyperbola, ellipse, circle, and all that. So we're going to determine whether there are function or not, or a relation. So in this case, let F represent a relation consisting of all order pairs having this form. It means if I have a number here x, for y I'm going to double that. So if x equal to 1, y would be 2 times 1. If x equal to 2, y would be 2 times 2, and so on. So in this case, if x equal to -2, y would be 2 times -2, which is -4. If x is equal to 0, y would be 2 times 0, which would be 0. So this would be a relation that whatever you have for the x, for y would doubles it. So you can locate those points, and if you connect these points, that would be actually the graph of your relation here, which is a straight line. So in this case here, mapping. So an arrow is used to map the order pair. So in this case, if I have order pair 1 and 2, means 1 maps to 2. This would be -2 maps to 5. So that would be like a point on the graph, -2, 5, and so on. Now, if you want to find the domain and range of this graph, this is an ellipse. We're going to talk about it in detail later. But the domain would be the value of x. So it would be all the number from -3 to 3. That would be your domain. And the range would be the value of y. Looks like it goes all the way from -6 to +6. So that would be your domain and range. And you can use a brackets because the endpoints are included here. So given the domain and range of each relationship here, in this case, those of you following this live with me, what do you think is the domain here is? Looking at this graph.
0, 0.
I hear 0. Anyone else? Remember, if I go back to the other one, we said the domain is from -3 to 3. This is where my graph exists, right? From -3 to 3, my graph exists here. But how about here? This is -infinity, +infinity. Does my graph exist from -infinity to +infinity? Yeah, there's no restriction there, right? It's not like the ellipse we had earlier. So all real numbers would be my domain. There's no restriction there. I can pick any number from x, Find the corresponding value for y. How about the range? Is my range is restricted? No. So the range and domain would be all real numbers. As a matter of fact, if you have a linear equation, a line that goes forever from both sides, the range and domain for all linear equations would be all real numbers. There's no restriction there. Okay. So negative infinity to positive infinity would be my range and domain. How about this one right here? This is a parabola. We're going to talk about parabola in detail later. But what is my range? Range would be starting from this point here, right? All the way to infinity, right? How about my domain? What is my domain? Remember, this parabola is going to get wider and wider as it grows, right? Doesn't it cover the whole x-axis eventually? Yeah. So the domain would be all real numbers, right? There's no restriction for domain. Domain would be all real numbers because this is going to get wider and wider and covers all the x on the right-hand side and the left-hand side same. But the range would be from this point, whatever that point is, all the way to infinity. So the domain would be all real numbers from negative infinity to positive infinity. However, the range is from, looks like it's -3 here. So -3 all the way to infinity. That's the range. Just by looking at the graph, you should be able to determine what the range and domains are. Okay, and then you can also use your calculator to establish that. So again, there are functions on your calculator where you can figure out what the range and domains for that, and you can explore that. A function is a relation in which each element in the domain corresponds to exactly one element on the range. So it means I cannot map the same number from x to different number on the y. That's the only restriction there. Let's take a look at this in more example. If x represents any elements in the domain, then x is called independent variable. If y represents any elements in the range, then y is called dependent variable. So let's take a look at this example here. In this one, given the domain and range, we already know how to do that, right? The domain and range, which one would be the domain, x or y? X, right? So if I were going to write the domain, I would include 1, 3, 5, 7, and 9. And for the range, I would have 2, 4, 6, 8, and 10. Okay, so it looks like we are mapping 1 to 2, mapping 3 to 4, 5 to 6, 7 to 8, 9 to 10. Is this a function? We said as long as we have one element from the domain mapped to another element on the range, it is a function. Okay. If I map one element from the domain to two different numbers in the domain, then it won't be a function. So in this example, this would be a function. This is a function. And we're going to look at some examples like in this one here. What's your domain? 1, 1, 1, 2, right? So the domain would be 1 and 2, basically. What is your range? 1, 2, 3, 4. Is this a function? No. Let's take a look at these points on the graph. If I assume this is my x-axis, this is my y-axis, 1, 1 would be 1 right here and 1 right here. So that would be 1 point right there, right? 1, 2, this is 1 and this is 2 right there. So I have a graph that passing through these 2 points, right? This point here would be 1, 1. This one would be 1, 2. I don't even have to go any further. If I find 2 lines right on top of each other on my graph, that violates the definition of the function. So we can stop right there since that's not the function. In other words, if I have a bunch of ordered pair in front of you without even looking at the graph, and somebody asks you, are these ordered pair represent function? What you do is you make sure that the numbers on the x-axis doesn't repeat. As long as the number at the x-axis doesn't repeat, then you can say, yes, this is a function. In other words, we don't have 2 points right on top of each other. Okay, so basically you don't have to even go further with the third one actually doesn't repeat, but as long as 2 of them repeats, it means you're done. It's not a function. So let's take a look at this one here. We have order pair x and y. So the domain would be those numbers, -4, -3, -2, -1, 0, 1. And then the y, the range would be that. Is this a function? Yeah, because if I go ahead and graph these order pairs on my line, -4 and 2. This is 1, 2, 3, 4. This is -4, and this is 2. That would be 1 point right there. Okay. Next one, this is -4 and 2. The next one would be -3 and 2. -3 and 2 would be right here. Are these points on top of each other? No, they're not right on top of each other. In other words, the number, if you compare these order pair, the first number doesn't repeat. As long as the first number doesn't repeat, it's function. The second number is okay to repeat itself, but not the first one. Okay, so this would be considered to be a function. So look at this one here. Y is equal to x minus 2. So y is always found by subtracting 2 from x. So in this case, this is like a straight line, right? Remember the both range and domain for that would be all real numbers. So if you would graph this, that would be a straight line, goes forever. So therefore, the range and domain would be all real numbers. Now, this is something known as vertical test. Remember I said the 2 numbers cannot be right on top of each other. If it does, then it's not a function. So basically, they're saying that if you draw a vertical line through your graph, if that vertical line is only intercept your graph at 1 point and 1 point only, then that would be a function. So this would be a parabola, right? The vertical parabola is a function, isn't it? However, the circle is not a function, because see, they're sharing these 2 points right on top of each other, and they're sharing the same x-axis. Okay, so the vertical test pretty much tells me that whether it's if you have a function or not. So if I have a horizontal parabola, is that a function? Does it violate the vertical test? If I draw a vertical line through this horizontal parabola, is this going to intercept at more than 1 point? Yes, right there. See, let's say this is 0. Let's say this is, I don't know, 1. And let's say this is 1 and -1, okay? All right, so look at this order pair. This would be 1, comma 1. This would be 1, comma -1. You see how they share the same x-axis? Before we said just by looking at the order pair, if they share the same x-axis, it's not a function. This is just another way to show that vertical test would help us just by looking at the graph to determine if it's function or not. If it intercepts your graph at more than 1 point, then that would be not a function. Okay, so a function is the correspondence in which each element x from a set called the domain is paired with one and only one element y from the set called range. So that statement should make more sense now after going through those examples. So if you have a bunch of order pairs, you want to make sure that the x doesn't repeat itself, doesn't map to different numbers in y-axis. So the function notation will look like that. Y is equal to f of x. That means that will read as f of x. We have a function f in terms of x. So in this example, if I have f of x equal to 3x minus 7, it means whatever number I assign to x, like 1, I triple that and subtract 7 from that, and that would be my y or f of x. So if x equal to 1, would be 3 times 1 minus 7 would be -15. If x equals to 4, 3 times 4 minus 7 would be equal to -6. So if I have a function, I can go ahead and evaluate any number of what? F of 3 then would be equal to, when x is equal to 3, f of x would be equal to 2, and so on. So you can look at the table. In this case, when x is equal to 3, y is equal to -9, so f of 3 is equal to -9. So this is how you map the domain into value of a range. So in this case, -2 maps to 6, and so on. So 3 in the domain is paired with 5 in the range, so f of 3 is equal to 5. So then we can locate those values on the x and y axis and actually graph them. So if you have a graph here and somebody asks you what is f of 3 is, you go to the x3 and see what's the corresponding number for y. Whatever it hits here would be 4 in this case. So that would be f of 3 is equal to 4. So we have the f of x equal to 5 minus 2x. We want to evaluate f of 4. You substitute for each x 4, and that would be your f of 4. For 5 minus 2 times 4, that would be -3. What's f of a? You substitute for each x a. You can actually find f of anything you want. You can find the f of symbol. Like if somebody asks you what's f of apple, it doesn't have to be a number. It could be a symbol. So here, the f of apple would be 5 minus 2 times whatever that symbol is, apple. Okay? So I could have expression. What is f of x plus delta y? Whatever that is, that's 5 minus 2 times x plus delta y. And so on. So here, what is f of a plus h? You substitute for each x, a plus h, and evaluate. What is f of 5x? You substitute for each x, 5x, and evaluate that. Okay, here we want to look at the linear function equation and inequalities now. So linear function, a function f defined by f of x equal to ax plus b, where a and b are real numbers, is called linear function. So as you notice that we don't have any square or cubed or anything like that. A graph is called a line, a straight line. Okay, here to find the x-intercept, you will let y be equal to 0, solve for x. If you want to find y-intercept, you let y be equal to 0 and solve for x. And we already know how to do that. So we can look at some example. Let f be a function, then any number c in the domain of f for which f of c is equal to 0 is called 0 of the function. So that would be where you intercept x-axis. That would be your x-intercept. This is where your graph intercept x-intercept. So if you have a graph f of x equal to minus 2x plus 5, what is the 0 of the function? Okay, so you let y be equal to 0, solve for x, or x equal to 0, solve for y. These would be the points where your graph going to intercept x and y axis. It's called known as x-intercept and y-intercept. We can easily use your graphing calculator also to locate those for you. You can explore that. These are some examples here that you can go through that. If it's a 100-gallon tank full of water is being drained at the rate of 5 gallons per minute, you want to write the formula for that. So as you can see here, f of x would be minus 5. The rate is negative 5x, and then it was originally 100. The constant would be 100. So this would be your function, f of x equal to minus 5x plus 100. So in this case, if you want to know what happens after 4 minutes, you really want to find f of 4. So you let each x equal to 4, and that would be the amount of gallons that have been drained out after 4 minutes, would be 80 gallons. So we can use that to find the x and y intercept if you graph them, and you can also graph those numbers you can go ahead and pause the session and go through this. A function defined by f of x equal to b, where b is real numbers, is a constant function. So we do have a constant function. You could have a vertical line or horizontal line. So in this case, f of x equal to -3, this is kind of like y is equal to -3. If we were going to graph y is equal to -3, what's missing here? Something is missing. X is missing. So really we have plus 0x here. So it means regardless of what I substitute for x, y would be equal to what? -3. If x is equal to 1, y is equal to -3. If x is equal to 2, y is equal to -3, right? So if you locate these points here, you notice that that corresponds to the horizontal line. Similarly, vertical line would be when y would be missing. Okay, and then that would be another example here where you can explore, and then you can use a graphing calculator to explore that. Another thing that you need to know, the slope, if you have 2 points, you need to know the formula. This should be a review again for most of you. y2 minus y1 over x2 minus x1 is the formula for the slope. If I give me 2 points, I can find the slope. You can label this x1, y1, x2, y2, and then plug into formula. So the slope here would be -4/7. What that means is from anywhere on the line, if I move 4 units up, 7 units to the left, I get back to the same line. Or if I look at it as the negative is at the top of the fraction, if from anywhere on the line, if I move 4 units down and 7 to the right, I get back to the same line. That's what it means by a slope being -4/7. From any point on the line, if I go 4 units up, 7 units to the left, I get back to another point on the line. That's what it means by the slope being -4/7. So here, if I have a graph, if I have a point and the slope, I should be able to graph them. Here, 2.1 is right here. From this point, it looks like the slope here is equal to -4/3. So from anywhere on the point, which is this point here, if I have to decide where the negative is, I can put it at the top or bottom of the fraction. Doesn't make a difference. If I go from here, 4 units down and 3 units to the right, I get back to another point on the line. So that would be my line right there. Or you can look at it this way. From any point on the line, if I go 4 units up, 3 units to the left, I get back to the same line. If you look at it as the slope being 4/-3. Notice that the slope is negative. When the slope is negative, you go from left to right, you go down. Your graph goes down. Okay? If the slope is positive, if you go from left to right, you expect to, let's say we have this situation here. So if you have someone here walking right here on the surface, so the slope here is what? What's the slope? Is there any slope here? No, slope is 0. When you go up, what would be the slope? Positive or negative? Positive. If you go on the flat, the slope is 0. What if you go straight down? No. Vertical line would have a slope of, the slope is changing y over changing x, right? y2 minus y1 over x2 minus x1, right? So these 2 points here on the vertical line don't have the same x-axis, right? So it means what? The number at the bottom fraction would be 0, something over 0. What is something over 0? Can you divide 0 into any number? What do we get? Undefined. So the slope of vertical is undefined because they have the same x-axis. So here would be slope is 0. So if I go up, the slope would be what? Positive. The slope would be positive from left to right. The slope would be negative. Well, yeah, if you're going down the hill, the slope would be negative. If you go up the hill, the slope is positive. If you go going straight on the flat, slope is 0. If you're going straight down vertically, the slope would be undefined because x2 minus x1 would be equal to 0. Okay, a vertical line with the x-intercept of k0 has an equation in the form x equal to k. So in this case, like example of that would be, let me go back to this. So if I have x is equal to 2, if we were going to graph this, it would be a good idea to put 0y here, remind you that there's no y. So regardless of what I substitute for y now, x would be always equal to 2. If you connect these points together, you can see that correspond to the vertical line. And the slope of that would be equal to undefined, because x2 minus x1 would be equal to 0. And so that would be another example here where you can look at the function. In 2006, online sale on Thanksgiving Day were $205 million. And in 2011, the sales reaches to $480 million. You want to find the average rate. So it's kind of like a slope problem here. So you would find x2 minus x1 over y2 minus y1. So the rate would be 55. So this is another example where you use the slope. And we can actually graph those on the line and find the linear graph for that. I'll let you explore that graph. Here, slope-intercept form. You probably heard y is equal to mx plus b is the general equation of the straight line. There were another one, y minus y1 is equal to m times x minus x1. This would be point slope formula. Okay, this is slope-intercept formula. This number b would be where your graph going to intercept y-axis, and m is the slope, how steep that would be. So if you look at this, you want to match these, it could be easily find out which one is which. So if the slope is, this number is the slope. If the slope is positive, means your graph going to go up, from left to right, go up, right? So for this one here, it would be either A or B, right? But here is a y-intercept. Y-intercept is 3. It means your graph gonna intercept at 3. So if this is 3, so look to me, this would be correspond to this graph. Y is equal to 2x plus 3. Intercept at 3, and the slope is positive, going up. So like this one here, this one intercept as -3, but the slope is positive. So this would correspond to y is equal to 2x minus 3. So this would be like graph A, this would be graph B. So this one, the y-intercept is 3. So it's right here, the y-intercept is 3, but going down. So this would correspond to D then, graph D. And this one, the y-intercept is -3 and going down. So that would be C. So just by looking at the slope and y-intercept, you can see which is which. And then in that case, like we said, which one is A, which one is B, and which one is C. You can look through this in more detail. So this would be another example where we can use a function y is equal to mx plus b. We want to estimate the number of text messages sent in 2012. So in this case, we let x correspond to 2006, and the y-axis we have a point 0 and 60. And b is equal to 60, and the rate is given to me as 407, so we can write our formula on that. Y is equal to slope is, or the rate is 407, and the y-axis in this case is 60, and this is you can find the value for any other number. So at x equal to 6, you can substitute that and then solve for y, and that's how you can find the text messages on any other years, as you can see there. And we can also graph them and find the x and y intercept on the graph, and just read the question, see what they're asking in this one, and find the function for those. Okay, so again, to find the x intercept, you let y equal to 0, solve for x, and to solve y intercept, you find x equal to 0 and solve for y.